Hello viewers. So in this lesson, we want to consider a topic, mathematical induction. So what do we mean by mathematical induction? Mathematical induction is just a method of proof. It's a method of proof we employ to prove propositions. You know, in some situations in mathematics, there may be need to prove the generality rather than individual cases, because if we are to go by individual cases, we may not be able to exhaust all the possibilities. So I will explain better with examples. But the method that is best suitable to prove the generality of a proposition is what we call what? Mathematical induction. So because you only need to know that the statement is true once, then you prove what the generality of such a proposition or statement. So I mix statement with proposition because proposition itself is mathematical statement. And what we mean by proposition, they are mathematical statements that is either true or false, but they are not both at the same time. So what we mean by what we regard as proposition, it may be actually or hypothetical statement that is either true or false, but not both. Now let's consider this statement. Okay, the sum of the first n positive odd integers equals the square of n. Here is a mathematical statement and here is a proposition. So here is a statement or proposition. So we want to employ mathematical induction to prove that this statement is true or false. We want to know either of the two, but this statement cannot be both at the same. It cannot be true at the same time false. Now, how do we work with this? Let's first interpret this statement. You know, this is a proposition. We have here the sum of the first n positive odd integers. You know, integers has the positive side and the negative side. For the positive, you have from 1 upward. The negative, you have from -1 downward. Now, the sum of the first n positive integers. Positive odd integers. And you know, odd numbers, they are just integers that are not divisible by 2. So now let's consider this positive. So it means you are starting from 1. And you know, the sum. So now after 1, and the next odd number after 1 is 3. So plus 3, plus 5, plus what? 7, plus, then the n term of this list of odd numbers will be 2n minus 1. So this is very easy to get when you apply the knowledge of arithmetic sequence or arithmetic progression. You know why? Why are we using the applying arithmetic progression? Look at this series. You can see the first term here is 1. The next term, 3, 5, 7. There is a common difference. Each term is generated by addition of 2, right? 2 plus 1, 3. 3 plus 2. 2 plus 1, 3. 2 plus 3, 5. You can see. So it means each term of this sequence of series is generated by addition of 2. So here is arithmetic series. And you know, under the arithmetic sequence and series, we have the formula for generating the n term of arithmetic progression. So the formula is Tn equals to a plus n minus 1 d. You know your a is the first term, your d is the common difference. So from this series here, our first term is a, which is 1, and our common difference d equals to 2. Compute the values and you will get this as the n term of this series. Now the question says the sum of the first n term of first n positive odd integers equals to n squared, meaning when we add everything here together, we are going to have a n squared. Now, what we need to do now is to prove this statement. Is this statement true or false? Now, to prove this, as I said earlier, we are going to employ the mathematical induction. Though we can use other methods to get this result. But what of the case when the series you have does not follow arithmetic or geometric progression? You know, we can't use this method. We cannot use the geometric one, meaning the only method that will be available then will be mathematical induction. And don't forget, this lesson we are treating this topic. That's why we are going to use mathematical induction to prove this. Now, to employ the method of a mathematical induction or induction, we have 2 steps. Please pay attention. We have 2 steps. The first step, you test for when n equals to 1. You test for when n equals to 1. Then step 2, you assume that n equals to k. You assume that n equals to k. Then use this assumption to prove that n equals to k plus 1 is true. You assume this, then you use this to prove that n equals to k plus 1 is true. So these are the steps we employ. Now, before we go into this, let's check. Let's use just normal layman method to check if this statement is true. Let's check for some cases. You know, when n equals to 1, this is the first term. First term is 1. So when n equals to 1, let's check. When n equals to 1, again we have 1 squared, that is 1. Meaning this first term, which is 1, is same thing as 1 squared. Okay, when n equals to 2, you are going to consider the sum of the first 2 terms. Here is the first 2 terms, that is 1 plus 3. 1 plus 3 equals to 4. And that is what? 2 squared. Okay, we use the first 2 terms. When we put 2 here, what do we have? 2 squared, which is the same, right? Let's check for when n equals to 3. When n equals to 3, we are going to consider the first 3 terms. 1, 2, 3. So that is 1 plus 3 plus 5. And that is just 9, which is 3 squared. It means from normal testing, this statement is getting there. That is, we can say this is true, but you cannot just conclude with just 2 or 3 tests. And that is what I mentioned earlier, that we use mathematical induction to prove the generality rather than individual cases. You know, for individual cases, we can see that this statement is true. But you can't just conclude that because you test 1 or 2, 3. What if you test the 110 or 1010 and the statement is not true? So what we need to use is this method of the mathematical induction, because according to method of mathematical induction, once you test once and the proposition is true, so the belief is that proposition is always true. But how do we show you people that the proposition is always true? Is by employing these 3 steps. Step 1, you test for n equals to 1, and from here you can see the first term is 1. So when n equals to 1, we have 1 squared, which is 1. They are the same. Then you assume for n equals to k, and we prove for n equals to k plus 1. So now let's go together to employ the method of a mathematical induction. Now, we want to prove this using mathematical induction. So now step 1, we test for when n equals to 1. So when n equals to 1, you know the first term is 1. So step 1, when n equals to 1. So now the first term is 1. So that is our P1, P to represent the proposition. So that is 1. Our first term is 1. When n equals to 1 also, we have what? 1 square. Are they the same? Both are the same. 1 equals to 1 square, which is 1. So meaning the statement is true when n equals to 1. Now what do we need to do next? We assume that n equals to k. This is very simple. The only thing you need to do here is that you replace letter n with k, and you assume that what you get is true. That is, the sum will give us n square, k square. So now we replace letter k, n with k here now. So we have a 1 plus 3 plus 5 plus 7 plus 2. Instead of n now, you replace n with what? K. K minus 1. Everything equals to, so you replace n with k again. K square. Now, that is part of step 2. Then before we move to step 3 to prove, what will be our expected result? Let's know our expected result so that we can prove towards that because one thing about when you ask to prove, you know where you are going. And not that you don't know where you are. You already know where you are going. You need to know where you are going so that you can know how to move in the lawful way, not just ordinary any way. So you move in a lawful way. That is, that follows the rules. Now let's check for our expected result. Look at this. Here is the first term. Here is the second term. Here is the third term. How do we generate each term? This is first term, this second, third, fourth. This is n term now. And you know, we are working with letter k. So this is k term. Now for this k, n equals to k plus 1, which is what we want to prove. What will be the k plus 1 term? You don't need to stress yourself. What you only need to do now, to know your expected result. Wherever you see k, you know, after this term, we said we have a 3. After this, we have 7. After, what will be the next term after this? You know, this is k term. The next term after this one will be k plus 1. Because if this is first, n equals to 1, n equals to 2, n equals to 3, n equals to 4. Then this is k. You know, we have 1, 2, 3. Each term is increasing by 1. So when you have k, if this is k term, then the next term after k will now be k plus 1. So now it means we have to extend this. We extend this one to k plus 1. So how do we, so now let's extend it. So extend to k plus 1. Let's do that. So now we have 1 plus 3 plus 5 plus 7 plus dot dot dot. Now this is the next term. We have a plus 2k minus 1. Then after 2k minus 1, you know the next term after k term, this is k term. Yeah, you know, you said n term from this AP. So now k plus 1 term now will now be 2 open bracket k plus 1 minus 1. Just replace letter k with k plus 1. Here we have just k. So to generate the next term, you introduce k plus 1. And once you introduce k plus 1, you know, we are replacing letter k with k plus 1. Meaning our expected result will also be what? Instead of ordinary k now, our expected result will be k plus 1 square. Now, we know where we are going. What next is to prove that if we make this assumption, then we can easily prove this. Now, to prove this is very simple. You don't need to stress yourself. Now, we have to prove that this side, which is the left side, will give us k plus 1, which is the assumption, our assumption, the expected result. We show that this side equals to this. This should be our expected result. This is what we are expected. Then what we need to prove that this side now will give us this, and that is very simple. How do we go by this? So now, look at here. We have 1 plus 3 plus everything up to this. All this, are they not the same thing as this? But they are the same. And what is the result of this? What is the result? Is it not k squared? It means we can replace all this together. We can replace it with what? K squared. So now we have k squared plus this one, which is a 2. I can open the bracket. Okay, let me just write first. 2k plus 1 minus 1. Now let's open the bracket. We have a k squared. Open this bracket, that's plus 2k plus 2 minus 1. Simplify this further, we have a k squared plus 2k plus 1. Now look at what we have. We have a k squared plus 2k plus 1. Can we just factorize this? If you factorize this, this is just very simple math, basic math. Here is a quadratic equation. So if there is any issue with your knowledge of a quadratic equation, you can watch my video on a quadratic equation. So this will be equals to k plus 1 square. If you factorize this, you get this, which is equivalent to this. Are they not the same? They are the same, and we are able to prove. Now it means your conclusion will now be, the sum of this equals to n squared. It means this statement is true. So the statement is true, it is not false. You are able to prove that this statement is what is true. And that is what we need to do. So in the next class, I give more examples on this topic. So, but among the ways we solve induction is this first example. Any question that you are given, just generate the next term after your n term or after your k term. Generate it, add it. If there is need to add it. Then you return the given one with what you assume. Then add the two together. Whatever you get, make sure you equivalent it to what you are expected to get. And that is just the simple way to prove by induction. So watch out for the next example in the next lesson. So thanks for watching. Don't forget to subscribe to my channel.